Hello my dear students, welcome to the class of 11th English Medium. The subject is Statistics, Chapter 2, that is Presentation of Data, brought to you by Vitan sir. Today we are going to discuss about the continuous frequency distribution. What is it? When the data is very large or the variable is continuous, we have to make use of this distribution to classify the data. The raw data collected is distributed in the number of classes, that is capital K, according to their class lengths, which is depicted by capital C. Here we can see an example of a continuous frequency distribution. These are the classes called 30 to 35, 35 to 40, 40 to 45 and 45 to 50. In this given distribution, there are 4 distinct classes. Therefore, we can say that number of classes capital K is 4. Now, if you check out individual classes, all of their differences is 5. That is 30 to 35, the difference is 5. 40 to 45, again the difference is 5. This difference between the bigger and the smaller value, that is the difference between the upper boundary and the lower boundary, is called the class length, which is depicted by C. In this question, the class length is 5. To determine number of classes and class length, the range of the data is to be found first. Range is found as difference between the highest observation and the lowest observation. It is depicted by capital R. In symbols, we can write it R is equal to HX minus LX. Similarly, it could be also written as XH minus XL. The difference is just in the symbols, the meaning is same. If number of classes, that is capital K, is given, we have to find the class length. How do we do it? Class length will be is equal to range of the data divided by number of classes. The ideal class length is in the multiple of 5, but it may vary. That is, usually the class lengths are taken as 5 or 10 or 20, something like that. But in extreme cases, we may take other values as class lengths. If class length capital C is given, then to find the number of classes K, K will be R upon C. Usually, number of classes are between 6 to 15. But again, in some cases, it may be less than 6 or more than 15. If class length of all classes is equal, then it is called frequency distribution with equal class lengths. The example could be given as follows: 25 to 30, the class length, the difference is 5. 30 to 35, again the difference is 5. 35 to 40, the difference is same, 5. If class length of the classes differ, that means each class has different class lengths, then it is called frequency distribution with unequal class lengths. The example, as you can see here, first one is 3000 to 5000. The difference here is 2000. That means the class length of the first class is 2000. Second class is 5000 to 10,000. The difference here is 5000. That means the class length is 5000. Third class is 10,000 to 20,000. That is the difference is 10,000. So the class length for that class is 10,000. So 2,000, 5,000, 10,000. This way the class lengths differ. So it is frequency distribution with unequal class lengths. If the upper limit of any class and the lower limit of its succeeding class is same, then it is called exclusive frequency distribution. Here is an example: lower limit and the upper limit. The value on the left hand side for any class is the lower limit. Value on the right hand side of any class is the upper limit. So as you can see here, the upper limit of the very first class, that is 150, and the lower limit of the next class, that is again 150. So when this kind of values are same, we call it exclusive frequency distribution. You can see the same thing with second and third classes. The upper limit of the second class is 175 and lower limit of the third class is also 175. So that way this kind of frequency distribution is called exclusive frequency distribution. If the upper limit of any class and the lower limit of its succeeding, that is the immediately next class, is not same, then it is called inclusive frequency distribution. You can see the example here. The first class is 30 to 39, then next class is 40 to 49, and again next is 50 to 59. The first class upper limit is 39, while the lower limit of the second class is 40. That means 40 comes after 39, it is not same. The upper limit of second class is 49 and the lower limit of third class is 50, which is again not same. So that's why we call it the inclusive frequency distribution. Let me clarify one very important difference. In the exclusive frequency distribution, I will take the example of first and the second class, that is 125 to 50 and 150 to 175. Now for example, my variable, the value itself is 150. That means it may belong to 125 to 150, it may belong to 150 to 175. In that case, 150 will not be put into 125 to 150, but 150 will be shown in 150 to 175, because the 150 as the upper limit is excluded. That means in 125 to 150, 150 is not included. Similarly, in 150 to 175, 175 is not included. So I will show 175 in the class 175 to 200 and not 150 to 175. That's why it is known as the exclusive frequency distribution. While in the inclusive frequency distribution, the classes are 30 to 39. That means 30 is included and 39 is also included in the same class. 40 to 49, so 40 and 49 both are included in the same class. Similarly, 50 to 59, so 50 and 59 are also part of the same class. So each and every class includes each and every value they show. That's why it is known as the inclusive frequency distribution. For the continuous data, exclusive frequency distribution is prepared, whereas for the discrete data which has very high range, inclusive frequency distribution is prepared. Okay, so whenever the data is continuous, we prepare exclusive frequency distribution, but when the data is discrete but with very high range, then we prepare inclusive frequency distribution. Let us take an illustration to understand this concept better. Figures regarding the sales of different items in a supermall during 4 weeks are as follows. We have the data here. We have to construct a frequency distribution by classifying this data into 8 classes. That means in the question itself, we are giving how many number of classes we are supposed to prepare. First of all, we have to start by finding out the range of the data. Here R is the highest observation minus lowest observation. If you check out the data here, the highest observation is 265 and the lowest observation here will be 80. So the difference, that is the range of the data, is 185. Next, we will use the k value and then find the class length, which we will be doing. The number of classes k is given, that is 8. So therefore the class length, that is C, will be R upon K, 185 upon 8, that is 23.125. So actually the class length which we should be following is 23.125, but any class length which such a decimal value is very difficult. So what we are going to do, for the sake of simplicity, we will be taking a class length in a nearest multiple of 5, that is 25 as class length. Okay, so the class length that we are going to take is 25, which is nearest to 23.125 and is the multiple of 5. You know, as I have told you, if the class length is in the multiple of 5, it becomes easier to calculate. As our lowest value is 80 and our class length is 25, we will start our class from 75, that is 75 to 100, 100 to 125 and so on. Now these are some things which we have to think on our own. If we start from 80, then 80 to 105, then 105 to 130 will be odd numbers. Rather, if we start from 75, then 75 to 100, 100 to 125 will be, simple to understand and to follow. Here I am again writing down the data because if I put it in the same slide, it will be easier for you guys to follow what I am doing. You don't need to write down the whole data once again. It is just for your information. An exclusive continuous frequency distribution of sales 1000 rupees during 4 weeks. This is the title of the classification which we are going to do. We will start with the table and then give the titles: sale in 1000 rupees, telemarks and frequency. Yes, we are doing the same thing which we did in the discrete frequency distribution. Now we will start with our classes 75 to 100, 100 to 125. We have to go on adding 25, 25, 25, 25 one by one. 125 to 150, 150 to 175, 175 to 200, 200 to 225, 225 to 250 and 250 to 275. We will stop at 275 as 275 includes our maximum value of 265. So there is no use in going any further. So our lowest observation 80 is included in the first class. Our highest observation 265 is also included in our last class. So this is how we prepare the distribution. Then comes total. Now we have to start with the telemarks. Okay, our first observation here is 228. Now 228 is a part of 225 to 250, so my first telemark will be there. Next is 125. Now 125 will be either 100 to 125 or 125 to 150. Now I have told you guys that when this value is repeated, we have to take it in the next class, that is in 125 to 150, means where 125 is the lower limit, at that we will put our telemark. Next is 100, so it will be 100 to 125, then it is 90, then it is 75 to 100, 115 it will be 100 to 125, 125 it is 125 to 150, 230 that will be 225 to 250, 220 200 to 225, 130 that will be 125 to 150, then 80 75 to 100, 95 again 75 to 100, 160 will be 150 to 175, 180 will be 175 to 200, 200 will be 200 to 225, again 200 again at the same place, 128 will be 152, or my mistake, 125 to 150, 120 will be 100 to 125, 85 will be 75 to 100, 185 will be 175 to 200, 140 will be 125 to 150, the diagonal bar. Next is 265, so it will be in the last. Then 230, 225 to 250, 135 will be 125 to 150, 127 will be the same, 100, then 145, 125 to 150, 150 will be 150 to 175, and last 210. Okay, so with this our telemarking ends. Now we will make a total of all the telemarks. The first one is 4, again 4, then 8, then 2, 2, 4, 3, 1, and the total is 28. So this is how we show the continuous frequency distribution. We will take one more, and with that we will end our tutorial. But let us see, during a season of 50 days, the data regarding the number of roses grown daily on the different plants in the garden are given below. Prepare a frequency distribution from it, having one class as 30 to 39. Okay, now the first thing which we have to see here, that these are the number of roses grown during the 50 days in the garden. Okay, so the number of roses are naturally not a continuous variable, the number of roses is a discrete variable, but this variable has a very huge data, and because the data is very huge, we can't follow the discrete frequency distribution, we have to follow the continuous frequency distribution. But as I told you that between exclusive and inclusive, when the data is continuous, we follow exclusive, when the data is discrete, we follow the inclusive. So as the rows is a discrete variable, but the data is large. So we will prepare inclusive continuous frequency distribution, starting with the range highest observation minus lowest observation. If you check out here, the highest observation is 99 and the lowest observation, if you check, it will be 17. So we will be getting the difference, 99 minus 17 is 82. Okay. Next, one of the class is 30 to 39. Now it is an inclusive frequency distribution, that means we have to include 30 and 39 both the values. So the number of the class length here will be 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. If you calculate it on your fingers, you will get that 30, 31 up to 39 will be 10 fingers. That means the class length here is 10. And when we divide our range with the class length, we will get the number of classes, that is 82 upon 10, 8.2. Once again, we can't take a class as a fraction. The number of classes cannot be in the fraction, and therefore to round it off, we will take 9 classes. We will consider that one of the class given in the question itself is 30 to 39. So we will start with something similar, that is 10 to 19. Why 10 to 19? We have to add this minimum observation 17 in this pattern. So 30 to 39, so before that it would be 20 to 29, and before that it would be 10 to 17. So we will follow the same pattern. I will once again write down the data here. I am writing it down, you don't need to do it, of course. An inclusive continuous frequency distribution of number of roses on different rose plants. Okay, that was the title of the distribution what we are going to do here. The each column titles number of roses, tally marks, and the frequency. Number of roses, as I told you guys, the first class will be 10 to 19. Similarly, next will be 20 to 29, 30 to 39, 40 to 49. Quite simple actually. Up to maximum was 99. So here we will take 90 to 99 and then write down the total. Okay, now the first data here. Now I will tell you that no number is repeated. This is an inclusive frequency distribution, so no number is repeated. So all numbers will only have one option. For example, the first value is 34. So 34 will be 30 to 39. Then 35 will be same. 37 will be same, and again 39 will be same. And then 39 has been repeated, so we get the group of 5 directly. Next is 54, that is 50 to 59, then 52 the same, then 69, that is 60 to 69, 71, that is 70 to 79, 75 the same, 74 the same, 76 the same. 84 is 80 to 89, 96 is 90 to 99. 23 is 20 to 29, 33 is 30 to 39, 51 is 50 to 59, quite simple actually. 39 is same, 30 to 39, 26 is 20 to 29, 46, 40 to 49, 65 and 65 are twice, so that is 60 to 69, again 60 to 69. 53 are twice, so 50 to 59, 70 to 71 will be 70 to 79 two times. Then 84, that is 80 to 89, 94 is 90 to 99, 34 is 30 to 39, 24 is 20 to 29, 90 to 99 once again, 19 is 10 to 19 first time, 18 is same, 10 to 19, 27 is 20 to 29, 17 is again 10 to 19, 38 is 30 to 39, 45, 40 to 49, 55, 50 to 59, 57 again 50 to 59, 66 is 60 to 69, 82 is 80 to 89, 85 is again 80 to 89, 35 is 30 to 39. We got two groups of 5 here. 19 is 10 to 19, 18 is again 10 to 19, we got a group of 5, 28 is 20 to 29, again a group of 5, 47 is 40 to 49, 52 is 50 to 59, and 64 is 60 to 69, and 75, that is 70 to 79. Now we will start making the total of frequencies. 5, 5, 10, 3, 8, 5, 7, 4, 3, and 50. So my dear students, I hope you liked how I tried to explain this continuous frequency distribution. Next time we will study some more topics. Till then, stay home, stay safe, and see you soon next time.